Hello everyone. Today we're going to learn how to figure out the number of valence electrons in an atom, and we're going to use the octet rule to be able to calculate the oxidation number of any atom on the periodic table that's in the main groups. We're going to start out with a sodium atom, and I've gone ahead and drawn the Bohr model for all of us. As we know, the atomic number tells us the number of protons, and in a neutral atom, electrons are equal to protons. We also know that we take the atomic mass minus the atomic number to find the number of neutrons. So our sodium atom has 11 electrons. That means that we put 2 electrons into the first energy level. We put 8 electrons into the second energy level, and we have 1 left over for the third energy level. Sodium is in the third period on the periodic table. All elements in the third period of the periodic table have 3 energy levels. So, when we look at our Bohr model, we see that in the outermost layer, sodium only has 1 electron. That is the valence electrons. Anytime you need to know the number of valence electrons, all you need to do is draw a Bohr model, figure out the number of electrons in this outermost layer, and there you go. It's just that easy. Now, the octet rule tells us that atoms are only happy when they have a full outer layer. And obviously sodium doesn't. It has 1 electron and 7 empty places. Sodium could steal 7 electrons to fill in these 7 empty spaces, but that's extremely difficult. Sodium is not strong enough to hold on to 7 additional electrons. So really the only choice that sodium has is to get rid of that 1 lone electron. That means the entire energy level disappears, and now sodium has a complete outermost layer. Well, sodium started out with 11 protons. And it started out with 11 electrons. But it just lost 1 of the electrons. That means there's an additional positive charge left over. So sodium now has an oxidation number of +1. Let's try this with another atom. Let's do beryllium. Beryllium has an atomic mass of 9 and an atomic number of 4. So we know that it has 4 protons, 5 neutrons, and it only has 4 electrons. So here's my Bohr model of a beryllium atom. How many energy levels does beryllium have? 1, 2. Every element in the second period of the periodic table is going to have 2 energy levels. How many valence electrons does beryllium have? 2. Those 2 numbers are equal in this particular case. They aren't always equal, so don't fall into the trap of thinking that's a pattern. Beryllium is not happy. The octet rule says that it wants to have a full outermost layer, and obviously beryllium doesn't. It could steal 6 electrons. That's going to be very difficult. So the easiest thing for beryllium to do is to lose those 2 outermost electrons. It started out as a neutral atom. It had 4 protons, it had 4 electrons. But it's now lost 2 electrons, and it now has 2 positive charges left over. So it has an oxidation number of 2. Not every atom is going to lose electrons, so let's learn about one that will steal electrons instead of losing them. Let's look at fluorine. Fluorine has an atomic mass of 19 and an atomic number of 9. So as we know, that means fluorine has 9 protons, it has 10 neutrons, and it has 9 electrons. There's only 1 empty space in this outermost energy level. Fluorine is in the second period of the periodic table, so it has 2 energy levels. How many valence electrons does fluorine have? It has 7. Fluorine could lose 7 electrons, but it has so many protons that's actually somewhat difficult for it. Also, it's a lot easier just to steal 1 electron and stick it in that empty spot right there. Well, fluorine started out with 9 protons and 9 electrons. Fluorine just stole 1 extra electron. It now has an unbalanced negative charge, so fluorine now has an oxidation number of -1. When you look at the periodic table, all of the elements in a group have the same number of valence electrons, and they will all share the same oxidation number.